this is what the Boothroyd chart says. Okay. So, it says you can analyze a particular assembly based on your alpha symmetry, your thickness and all that. Okay. So, I will just there is some scheme that they say, okay. They give you a 2-digit code that you need to look at, and finally it will give you the time and all that. Okay. So, I will just take you through this. I mean, this is a larger chart. For projection purpose, I am just showing you like the top part of it. Okay. I will just take you to a couple of rows and then we will look at a case study. Okay. So, what this says is there is a key, it says. Okay. So, here it is one hand, and below this there will be a key that says it is 2 hands are required. So, right now we will just imagine one hand. What this one says is part can be grasped and manipulated by one hand without the aid of grasping tools. That is what it says. The second one will be still 2 hands or one hand with tool or something like that. Okay. So, this particular stuff, it says first, can your part be handled without a tool? Can it be handled by a single hand? Yes. Then you need to look into, these are the options that you have, that is all. So, the first one it's asking is what is your alpha plus beta? Is it less than 360? Is it less than 540? Is it less than 720? Is it equal to 720? This you know how to do that. So, once you do this, this is going to be the first digit. You are going to have 2-digit code. The first digit is based on your symmetry, whether it is 0, 1, 2 or 3. Let us say it was 2. I am just giving a number. Okay. Now, you need to figure out what is your second digit. What you are going to do, you will have to see all the way in the top column. It says, sorry, top row. Parts are easy to grasp and manipulate, part present handling difficulties. So, you decide whether it is easy to grasp and manipulate. If yes, then you answer whether it is thickness is greater than or thickness is less than or equal to 2 mm. If you say thickness is less than or equal to 2 mm, then you look at what is the size. You remember we spoke about symmetry number 1, we spoke about thickness number 2, we spoke about size number 3. So, that is the reason I discussed only that, but there will also be other things when you go into this. See, parts need tweezer for grasping and manipulation. Under that you will have restricted access, restricted vision, for all that you will have time based information. Okay. Then what you do is this, you look at this and let's assume in this case the size was greater than 6 mm. Then what happens, your 3, your second digit code is 3. So, for 23, what is the time? The entries here are time 2.36 seconds. Okay. This is always a question, how do you come up with 6, the second digit in seconds, microseconds. Okay. So, it says for a particular stuff where your first digit was 2, which means this was the symmetry, and the thickness was less than 2 mm and the size was greater than 6 mm, the time required is 2.36 seconds. Okay. Now, the beauty is you have not gone to the lathe, you have not gone to the workshop. Sitting on your CAD model, I can tell you this is what is the time it is going to take. Okay. Then you can say, oh, 2.36 seconds, I am going to make 100 such components. So, it is going to be, I do not know, 236 seconds. Okay. And then one labor is going to cost me so much money for 1 second. So, for 236 seconds, what is the cost? So, you can do that. So, assembly cost you can actually accommodate it during the design stage itself. That's the beauty of this. Okay. So, here is a controller assembly case study. So, this is also adapted from the book. So, you can go in detail, you can look at it. Okay. So, we'll go through this, but before that I will tell you this is what they came up with, the final proposed design. Please watch this. This is where they started. Okay. They analyzed this whole setup, then they figured out what can be eliminated, how can you eliminate it, what can be replaced and all that. Then they came up with this reduced design. Okay. So, naturally the assembly cost was much lesser in this compared to the other one. Both of them do the same function. So, okay. So, we are going to look at this study of a controller assembly particular thing, right. It is an exploded view, it is an exploded view, it is a compressed controller assembly kind of stuff. We are not going to go through all the parts, okay. Probably the I'll look into it, okay. So, the deal is, first thing I guess they are taking this pressure regulator, okay. Yeah, they are taking the pressure regulator. Name of the assembly is the main sub assembly, and then they are calling all the parts, right. So, if you go back to this, they have a pressure regulator, they have a connector, they have a tube assembly, pressure regulator, tube assembly, and then the metal frame, nut, everything they have put it here part by part. Then what they are trying to do is this, they are asking the number of items, okay. For instance, the pressure regulator, it is only one. The screw, there were 2 screws, so it has to be multiplied by 2 at the end. Then similarly, all other, at least in this particular page, is 1. Then they ask for the manual handling code. So, this is just the sheet, you start by filling each one of the rows. We will figure out how they came up with this 30, we will look at that, okay. Then handling time per that is 1.95, and then this is the handling part. Similarly, you will have an insertion thing also. So, in the insertion, the code is 00, the corresponding time is 1.5 seconds, then the total time is the total handling plus the total insertion, which is 3.5, and the operation cost, they have some numbers, they multiply it, say it is $30 per hour. This is way back, okay. No one works for $30 now. So, 3.5 sorry 2.9, and then the figure for the minimum number of parts. You remember whether this part is required or not, it is 1. See, for instance, nut, as we discussed, fasteners are not minimum, they do not qualify as minimum number of parts. So, it is 0. Strap, the screw, the adapter nut, the tube assembly, they do not need to be. So, anyway, so now what we will do is we will just look at this pressure regulator, for instance, okay. This is the pressure regulator. What it says, it is 114 by 58, which means the length is 114 and the width is 58 in this case. So, that is the will be useful for your size, your thickness estimations. Now, what you need to do is you need to go back to this guy. What will you ask here? Can it be handled in one hand? I guess in this particular case it can be handled in one hand. Okay. So, for that pressure regulator, what do you think is your symmetry? This is your pressure regulator. What is your symmetry? What is your alpha? What is your beta? So, this is your insertion angle, right? This is your insertion angle. So, your alpha is something that is perpendicular to it. So, in order for, so it is 360, okay. You have to be careful because there is a tube assembly, okay, and the tube assembly has a hole in this side where it is connected to the sensor, okay. So, it is not 0, meaning like if this was not there, sorry, if this particular part was not there, then probably it is 0, but in this particular case, yeah, I mean there are two ways of looking at it. It could either be 180 or it could be 360 provided, but then the whole setup needs to come to the other side. This entire setup needs to come to the other side. Okay.
Sir, since the other setup is similar to a wire, can we wind it around?
No, hold on. That is design guideline. Further, right now in the existing setup, you need to say what is the code and all that, so that it will give you a estimation of the time that is required for this particular assembly. In this particular assembly itself, you are suggesting something. What is it? This is a tube assembly.
Sir, the tube assembly. Whichever way parallelly we rotate, as in parallel to the axis.
Okay.
Whichever way we rotate, the tube will get adjusted.
No, the tube will not get adjusted because you see here there is an adapter nut which will go through this. You can see this thing, it comes through this, correct, which connects to a sensor. The sensor is clamped. So, if you change this guy from here to here, the tube need not necessarily come that far, at least the way it is drawn. Okay. So, if I remember, they use 30, right. So, it should be alpha plus beta equal to 720, right. So, this guy is 360. So, alpha plus beta was equal to 720 in this particular case. So, what I do is I go to this chart and then I say this is the one, okay, and then I choose this is to be the this is to be the first digit. So, there are going to be 2 digits, the first one is 3. Now, what is the second digits? The part is easy to grasp and manipulate. What do you think? It is easy to the height is about 114 mm, which is 11 to 12 centimeters, okay, and the width is about 6. Still it should be easy for us to hold it. The next one should be your thickness and then the size, right. So, what is the thickness? Is this a cylindrical part or a non-cylindrical part? It is not a regular cylinder. So, whether it is cylindrical or not. So, 1 side, 2 side, 3 side, 4 side, more than 5 sides are there, that is one thing. And what else was the condition?
The length should be greater than the dia.
Is the length greater than the dia? Yes, it is. Okay. So, it can be considered as a cylindrical part in that case. So, what will be your thickness then? The diameter, yes. This is 114 by 58. Okay. So, that 58 is what? Okay, I guess so. So, if you go, the thickness is greater than 2 mm, 58, right, yeah. Greater than 15 mm because it is 58, hence your second digit will be 0. Second digit will be 0. Did you get it? Yes or no? Fine. So, now this is 30, you go back to this chart now and the corresponding time would have been 1.95 there if we had seen. 30 is 1.95 seconds. Similarly, there is a chart for the insertion, okay. Then you can go and you will find out it will be similarly, okay. In that you will find out a code to be 00 and then the insertion time will be 1.5. So, if you add both of these guys you will get 3.5. So, this is close to 2, 1.5 is 3.5 and you can just put the operation cost, the minimum part, okay. Is it a minimum theoretical figures for minimum parts, right? Sorry, yeah. So, the question is it rotating with respect to the other parts? All other parts, I do not think it is rotating, okay. But we do not know the details, we need to go through the the controller assembly details to do, but probably this is supposed to be made out of a different material compared to any other material that it bonds with. Hence, it qualifies as a theoretical minimum number of part, hence the value 1. Okay. So, we will see the strap, this guy is a strap. Okay. Here what it is written is 50 times 20 times 16. Okay. So, naturally 50 is the length, 20 is the height here and this thickness is 16. Okay. It is 1, what is the manual handling code for this guy? Can the strap be handled by one hand? Yes. Yes. And then what was its alpha plus beta? Let us see here. Okay, so it is getting inserted this way, it is getting inserted this way. So, the axis that is perpendicular to that. So, if you are going to rotate it, how many times?
360 minus
So, alpha is 360, beta is 180. So, 540. Okay. 540 means it is 2, because here it is less than 540, less than, greater than or equal to is here. So, it is 2, and is the part easy to grasp and manipulate? Yes. Was the thickness greater than 2 mm or was it less than 2 mm? It is greater than 2 mm. Was it greater than 15 or less than 15 or less than 6? Greater than 15. So, it is 20. That is the handling code. We should actually look at this. I'll just, this is a small digression, but I'll show you what is the continuation of this one. Okay, this chart you just saw this, right? The continuation of this chart is this. This is the last part 720, right? So, the second part is, it says parts need tweezers for grasping and manipulation. The legend, I mean the key is one hand with the grasping aids. You might still be able to handle it with one hand, but you need grasping aids. Then you look for the symmetry and then you go through this. The last one is you need both the hands for manipulation. Okay. Then parts present no additional handling, parts present additional handling difficulties such as sticky, delicate, slippery, etc. So, all this come into here. Parts present handling difficulties, it's even written here. Parts need standard tools other than tweezers, parts need special tools for grasping. If it is a regular screwdriver or you need a 5-point screwdriver and all that is specifically, okay, the numbers increase accordingly. The final one is parts can be handled by one person without mechanical assistance. Okay. Parts do not severely nest or tangle, are not flexible. The part is added but not secured. This is insertion. So, we just spoke about assembly, right, handling. Similarly, there is also a table for insertion. The key in this is, first one is the part is added but not secured. In the second one, the part is secured immediately. Okay, just because you are going to put two parts together, it does not mean that they are secured. Okay, they might still be dancing. So, then you still need a hand to hold it so that you can put the next part to it. In the second one is the part is secured immediately. We look at this guy, the manual insertion code. Okay, for the first part, the pressure regulator itself, we will revisit this. What it says is, the part is added but not secured. There is a, somewhere there is an explanation to this. Addition of any part where neither the part itself nor any other part is finally secured immediately, because you are currently taking only one part right now. So, it is not secured. So, it will automatically fall into this part. Part and the associated tool cannot easily reach the desired location. That is not true in our case, right. We can easily reach out to that. So, part and the associated tool can easily reach the desired location, hence it is 0. And the other one is, after assembly, no holding down required to maintain orientation and location. For that particular part, it is okay at this point in time. The one that gets bounded on it or fastened on it is what we need to check next. Easy to align and position during assembly, no resistance to insertion. So, it is 0 and 0, that is why they had 0 and 0. The time was 1.5. Okay. Now, we are looking at the strap. So, alpha plus beta, yeah, and it was 20. So, we will look at it. Strap is 20, the corresponding time would have been 1.80. We will see what it takes for the manual insertion. Okay. So, okay, the strap, the question is, the part is added but not secured, is that true? You see the part, this part is added to this. Is that part itself or the one on which it goes, either of them are secured? Yeah, the part is secured, right. But is that secured immediately? That is also the question. Careful. This guy, you put the sensor through this hole, and after that you place the strap on top of it. Is it secured?
We need to fasten.
Yes, you are right. Just trying to make sure. Okay. So, be careful. The screw is what is going to make it secure. Just because you put the strap, it is not secure. The strap will enable, but finally the screw is the guy who does the job. So, in that the part is added, but it is not secured because the screw is a different part and tightening the screw is a different action. Okay. The part is added but not secured. So, you still, I mean, the part can easily reach the desired location, there is no problem, hence it is 0. Then what you do is you look at, after assembly no holding down is required to maintain the orientation and location, that you tell me, is this correct? This guy. Are you able to read that or no? Okay, I am reading it. It says after assembly no holding down required to maintain orientation and location. You need to hold it. So, it is go to the second one. Holding down required during subsequent processes to maintain orientation or location, correct? So, we are going to look at this particular one. Yes. The one that reads out next is easy to align and position during assembly, not easy to align or position during assembly. In my opinion also it is easy to align and position during assembly, but then they have chosen not easy to align and position during assembly. Okay. And then they say there is no resistance to insertion, which is correct for us. We also would say there is no resistance to insertion. So, they have chosen 8, we might have ended up choosing 6, by which we are losing about 1 second, which is fine. We need to go through the details, I kind of haven't done, we can just go through that and then it will tell you, because they would have discussed each part in detail. So, it is not easy to align for some reason, then they have chosen 8 I guess. So, that is why you will have 0, 8 here. Maybe. Okay. So, as a designer you will know, because you are the one who is designing, right. So, it is 6.5 and then you are going to add 6.5 to 1.8, you will get 8.3, the corresponding hours, whereas the strap is not a rotating part and it need not be of a different material, hence it is not a theoretical minimum number of part, it is not a minimum number of part, it is not an absolute requirement. Okay. And then let us take the metal frame for instance, okay. This guy, I am not going to do the entire stuff, I am just doing a couple of things, right. So, this is a metal frame here that we are talking about, okay. And this one it says 114 by 77 times 51, okay. That is for just for your this thing. So, yeah. So, this one is going to go through this metal frame, through this plastic cover, and then it will be tightened using the knob. So, for the metal cover, what is your alpha plus beta? It was a L shaped stuff. $360 plus 360, it is 720, and then it is easy to grasp and manipulate, greater than 2 mm. So, it is 3 and 0, 1.95. So, let us worry about the insertion thing. Okay. Now, the part is added, but is it secured? No, it is not secured. So, the part is added, but not secured. So, we will have to look into this, correct. After assembly no holding down is required to maintain orientation and location. Holding down is required during subsequent process. Which one is correct?
It does not require any holding down.
This does not require any holding down? It will require, right, because this goes and then there is a screw, there is a nut that goes and tightens it, and after that the plastic cover comes, and finally you have a knob. Okay. So, it does require holding down is required, easy to align and position during assembly, not easy to align and position. So, I guess we would choose 0 and 6, we will see what they have done. Hey, they have done the same thing, 0 and 6. Okay. So, 30 and 5.5 and then the total would be 7.4 and the cost is 6.2. Okay. So, just before I wrap up, we will just look at probably the screw. Okay. These two screws that we are talking about, it says 10 by 9. Okay. So, there are two screws, the handling code is for a screw, what is your alpha plus beta? Screw is being inserted this way. So, your alpha symmetry is how much? 360. What is your beta symmetry? Has someone ever told you that the screw has to be put only in this axis, in this direction, it cannot be put in this direction, you can put it in, so it is 0. So, it is 360, which means it is 1. Okay. So, we are going to look into this one, and yeah, is the part easy to grasp and manipulate? Yes. Is it greater than 2 mm? What did we see? 10 cross 9. So, it is greater than 2 mm. And is it greater than 15? No, it is between 6 and 15. So, it is 1, 11. So, we are looking at this guy. I do not know, is that right? Yes. Okay. And the insertion, manual insertion code. Yeah. The part is added, but is it secured or not? I will read this again. Addition of any part where neither the part itself nor any other part is finally secured immediately. Upon putting the screw, is the screw secured or does it secure the other part?
The first screw does it, if you put one screw, does it secure the other part? If you put both the screws, it does secure.
You are actually talking about both the screws because you are taking 2 at a time. Yeah, you are not taking screw 1, you are not taking screw 2, you are taking 2 screws at a time. It is secure. So, we are going to look at part secured immediately. Okay. So, I will just read this out. Addition of any part where the part itself or other parts are being finally secured immediately. Part and the associated tool can easily reach the desired location and the tool can be operated easily. Correct. Just put the strap and it is the outermost part, so you can do that. So, we will take 3. Okay. And then no screwing operation or plastic deformation immediately after insertion. Bracket, it says snaps / press fits, circlips, spire nuts, etc. Easy to align and position with no resistance or insertion, not easy to align or position during assembly and or resistance to insertion. It is neither of these two, correct? It is not a snap fit, there is a screwing operation that is required, it is a screw. There is a separate thing that says screw tightening immediately after insertion, this is a separate thing, okay. And under that, easy to align and position with no torsional resistance, not easy to align, and they have chosen that part of it, okay. They have chosen 3 and 9, which is 3, 9, and the insertion time is 8 in that, the total time is 19.6 and 16.3, but fasteners are not counted as theoretical minimum number of parts. So, it is 0, the 2 parts. Okay. So, finally, why are we doing all this? To get what? Assembly efficiency, exactly. So, what you do is this, you do all these stuff, you add up all these guys, finally that will be your theoretical minimum number of part times how much time does it take for the original assembly to be done, that is in the denominator, and the one in the numerator is the ideal time. The ideal time is usually less. Yeah. So, the total assembly time was 27 seconds, the theoretical minimum number of parts was 5. Yeah. Finally, what they did is they kind of say that it is a 7% efficiency. after the change, the design change, they have been able to increase the efficiency to about 18%. Okay. So, we will see how they go about doing it. Okay. So, what they did is they looked at all these stuff and yeah. So, they are also giving some description, okay, what you can do actually. Okay. For instance, the earth lead can be a snap fit, okay, and for the PCV you need to add and hold down. So, they are doing all that, and based on that they kind of come up with a design change where they say combine the plastic cover with the frame and eliminate 3 screws and reorientation. Plastic cover and frame. This is a plastic cover. Okay. This guy is the plastic cover and the frame. This is a metal frame. So, what they are telling is you can kind of integrate this guy into this guy, so that you can get rid of this, you can kind of get rid of this and you can get rid of this. So, 3 screws you can get rid of, but you need to integrate this guy into this guy. He is a metal frame made out of some material, and this is a plastic cover that is made out of some material. Okay, but you have to try to integrate this. It might mean that you will have to change this material. Okay. So, like that, eliminate the strap and 2 screws. Instead, you provide snaps in plastic frame to hold the sensor if necessary. You do not need a separate strap and then tighten the screws and all that. Okay. Eliminate the screws holding the PCB assembly. So, like that they look at all that. So, they are also seeing what are the items that are getting affected and what is the time in savings if you end up doing that. Okay. This is just by removing the 3 screws, they have saved about 54.3 seconds. Okay. And then finally, they come up with this design, which is implemented. Okay. This is a original case study that they show. Okay. So, they have kind of it is still a plastic cover, they have removed the metal frame, but now this guy directly goes and sits on that. It does not have a metal frame in which it sits, which is finally knob and all that is coming. It is directly goes and sits into this. Okay. So, that is just to give you an idea on how to estimate the assembly efficiency and how it can be used to come up with a better design.